Somewhere on Earth right now, someone taps send. A tiny green arrow flashes on a phone screen, perhaps sending a simple message that reads, "Are you coming?" It feels instant, effortless, almost magical. But at that exact moment, something remarkable begins. That small message doesn't simply jump from one phone to another. Instead, it starts an extraordinary journey across invisible digital highways, diving into underground cables, passing through silent data centers, and racing across the planet at nearly the speed of light, all in less than a second. Behind that instant delivery lies one of the most complex technological systems ever created by humans, a system most people rarely think about. Imagine it's late at night. You're sitting in your room, your phone glowing softly in the dark. You open a messaging app and send a message to a friend who might be thousands of kilometers away, perhaps in London, New York, or Tokyo. Within seconds, 2 blue ticks appear on your screen. Delivered. It feels simple, but if we pause for a moment, a fascinating question emerges. How did that message travel across oceans, countries, and continents faster than the blink of an eye? And why does such a system even exist? For most of human history, communication across long distances was painfully slow. Centuries ago, sending a message around the world could take months. Letters traveled by horse, by ship, or through caravans crossing deserts. Entire wars could begin and end before news of them reached distant lands. The first major breakthrough came in the 19th century with the invention of the telegraph. For the first time, messages could move as electrical signals along wires, reducing communication times from months to minutes. Later, the telephone allowed voices to travel across continents, yet even then communication had limitations. International calls were expensive, text messaging was basic, and sharing photos or videos across the globe was nearly impossible. Then the internet arrived and changed everything. By connecting computers worldwide, it created a global network capable of transferring information instantly. Soon after, companies began building platforms that allowed people to communicate through this network. Messaging applications emerged, and one of the most widely used today is WhatsApp, used daily by more than 2 billion people. Yet the true wonder isn't the app itself. It's the hidden journey each message takes. When you type a message and press send, your phone immediately converts that message into something computers understand: data. Your sentence becomes a small packet of digital information, essentially a bundle of numbers. You can think of it like a digital envelope containing your message along with instructions, where it came from, where it needs to go, and how it should travel. That packet is then sent from your phone into the internet. If you're using Wi-Fi, the message first travels to your home router. If you're using mobile data, it goes to the nearest cell tower. From there, it enters the vast network that forms the internet. Here's where things become even more interesting. Your message usually isn't sent as one single piece. Instead, it is broken into multiple smaller packets of data. Each packet can travel along a slightly different route through the network, similar to cars taking different highways toward the same city. This design allows the internet to find the fastest path available at any given moment. Along the way, powerful machines called routers act like traffic controllers for digital information, constantly deciding which direction each packet should take next. Before reaching its destination, your message might pass through dozens of routers, scattered across cities and countries. All of this happens in mere milliseconds. Despite the way people often describe it as a cloud, the internet is actually very physical. Beneath oceans, deserts, mountains, and cities lies one of the largest infrastructures humanity has ever built: vast networks of fiber-optic cables. These cables carry data as pulses of light. When your message enters one of these cables, it becomes flashes of laser light racing through glass fibers thinner than a human hair. These pulses travel at roughly 2/3 the speed of light, around 200,000 kilometers per second. Some cables stretch across entire oceans. For example, connections between Europe and North America run thousands of kilometers across the dark Atlantic seabed. Hidden in the depths of the ocean lies the backbone of the global internet, and your message might travel through several of these underwater cables during its journey. But cables are only part of the story. Along the way, your message often stops at enormous facilities known as data centers. These buildings are the beating hearts of the internet. Inside them are thousands, or sometimes hundreds of thousands, of servers, powerful computers that store websites, applications, and data. Endless rows of machines fill these buildings, with blinking lights and powerful cooling systems running constantly to prevent overheating. When your message arrives at a server associated with the messaging service, the system verifies who sent it, ensures it's properly encrypted, identifies the intended recipient, and then sends the message back out across the internet toward the receiver's device. This entire process usually happens so quickly that it feels instantaneous. Security plays a crucial role during this journey. Messaging services like WhatsApp use a technology called end-to-end encryption. This means that when you send a message, it is locked using a digital key that only the recipient's device can unlock. As the message travels through cables, routers, and servers, it remains scrambled, essentially a secret code. Internet providers, hackers, and even the messaging platform itself cannot read the content. Only when the message reaches the recipient's phone does it finally decrypt and appear on their screen, accompanied by the familiar double check marks indicating delivery. This process repeats on a staggering scale every moment. Around the world, people are constantly sending messages, friends chatting, families sharing photos, businesses negotiating deals, doctors coordinating patient care, and emergency responders communicating during crises. Every day, users send more than 100 billion messages through WhatsApp alone. That is more messages in a single day than humans sent through traditional postal systems over centuries. For billions of people, these messaging platforms are no longer just apps. They are essential tools of daily life. Businesses accept orders, teachers send announcements, and communities organize events entirely through messaging. Yet most people never stop to consider the technological journey behind a single message, a journey involving cables crossing oceans, lasers flashing through glass fibers, powerful data centers verifying information, and complex encryption systems protecting privacy. It is an immense collaboration of machines and infrastructure working together so that two people anywhere on Earth can communicate instantly. Looking ahead, the future of communication may become even more remarkable. Engineers are developing satellite-based internet systems in which thousands of satellites orbit Earth and relay messages through space, potentially connecting even the most remote regions of the planet. Researchers are also exploring quantum communication, a technology that uses the strange properties of quantum physics to secure messages in ways that could make interception almost impossible. At the same time, new generations of fiber-optic cables promise dramatically higher speeds, capable of transmitting enormous volumes of data in fractions of a second. Artificial intelligence may soon manage global internet traffic automatically, constantly adjusting routes to optimize performance for billions of messages in real time. However, these advances also introduce challenges. As humanity becomes increasingly connected, issues like cybersecurity threats, data privacy, and infrastructure vulnerability grow more significant. The global internet depends on millions of servers, thousands of cables, stable power supplies, cooling systems, and teams of engineers monitoring everything around the clock. It is one of the largest and most complex systems ever created by humans, yet most of us rarely see it. Instead, we see only the final result: two small check marks confirming that a message has been delivered. Behind that simple notification lies a technological journey spanning cities, oceans, and continents. A race through cables, machines, and beams of light that connects billions of human lives. The next time you press send, it's worth pausing for a moment to appreciate what truly happens. That tiny message is not merely leaving your phone, it is beginning an extraordinary journey through the hidden nervous system of our planet, traveling across the world in less than a second and reminding us just how astonishing our connected world has become.